Meta is a statistician and a data miner. She doesn't self-identify as a data scientist. She's over in the UK to give a couple of talks, including the Bank of England tomorrow and Imperial College shortly afterwards. And the Imperial College talk will be an open talk, so you can register for that. And I think you'll mention a bit about that later on.
I will.
Meta is also the author of Data Mining for Dummies. We're going to have an interesting talk about a process that's well known in other fields, but was new to me. So I hope to be educated thoroughly about a formal methodology for doing some of our work. So please welcome Meta.
Good morning. Let's warn everyone what we're going to be speaking about, so if it's not to your taste, you can sneak out the back very quickly. I'm going to explain to you what CRISP-DM is and where it's come from. I'm going to explain the phases of the process. And then I want to talk to this group of people very specifically about where CRISP-DM lies today and why there are good reasons why you may want to become involved with it. So who am I to tell you this? It's been mentioned I'm the author of Data Mining for Dummies and some other books. I'm a data miner. I don't use the term data scientist. Some people call me that name. But I was trained classically as a statistician, and it was enough of a challenge to get used to data miner. And I have been doing hands-on work in data mining and in text mining since the 1990s. And that's a long time for those fields. I've done many successful projects, and in particular, my focus is on two things. It's on helping people actually make money from their analysis. And professionally, I put food on the table by working with folks like you, people who identify as data scientists, data miners, statisticians, web analysts, engineers, and any of a host of other data analyst sort of titles, technical titles, learn to communicate with everyone else, because many people cannot understand us. So CRISP-DM stands for Cross-Industry Standard Process for Data Mining, and it is the dominant process for data mining. Where did it come from? Well, the term data mining has been in use for a long time. It's not really clear how long, at least since the early 90s, as a very informally used term. In the 1960s, people used a lot of broad terms, and largely in a negative way, things like data fishing, data diving, and data mining might have been in there too. So the term is not so new. But data mining, in its modern sense, and in the sense that I've been using it for many years and wrote a book about it, has been around since the early to mid-90s. Now, there was, in 1989, a workshop called Knowledge in Data Discovery. And these workshops continue to go on. And that was a seminal moment for data mining. At that time, a broad knowledge and data discovery is actually KDD, knowledge and discovery in databases, was defined as a kind of a linear process. And the term data mining, may not at that moment, but soon thereafter, began to be used there as a narrow step in it, the algorithm step. The usage has changed a bit over time. So in 1994, the first, what I would call a modern data mining workbench was created. It was called Clementine, and if you're young, you may only know Clementine by the name it has today, which is IBM SPSS Modeler, because Integral Solutions Limited, who first created this, got bought by SPSS. SPSS got bought by IBM, and so they gave it the longest, most awful sounding, not at all memorable name that they could. And if you meet today's IBM employees or product users. All products that used to belong to SPSS are called SPSS. So it's very hard to understand which product they're talking about. They might be talking about what used to be Clementine. I think we should just call it that, the product formerly known as Clementine. Or they might be talking about any of a number of other products. So what was important about this? Right? This positioned data mining as something that business people do, people who are not trained as statisticians, not trained as programmers, but people who are experts in the work that they do. So that work might be making a chemical factory work better. That work might be selling newspaper subscriptions to you. That work might be running any kind of a business, and I say that loosely because the business might in fact be a government operation or a nonprofit. But they're not expert data analysts. They're not expert programmers. They're not meant to be. So how was it possible to enable that group of people to be making discoveries in data? Well, they got a graphic user interface that was perfectly suited to them, and it's called a visual programming interface. And today you see them in other kinds of tools as well. And in the early versions, the algorithms that were available there were very strictly the ones that were associated with data mining. So they were pattern recognition. There were no traditional statistical tools, I think, in the very first versions. Soon thereafter, people started using this stuff, and they realized we need to define a process. By 2000, that process had been defined. How did it happen? Well, a group of key data mining organizations, Daimler-Benz, Integral Solutions Limited, and NCR, only one of which is still called by that name today, said, we're doing this, we need a process. They wanted something that everyone could use, no matter what tools they used, what industry they were in, and for that matter, what budget they had. So they got funding from the European Union, and they formed a special interest group. And that special interest group attracted over 200 organizations. They met in several places, and they put together this very nice step-by-step guide to what you need to do data mining. And it was a much broader process than just algorithms. So already what data mining was redefined as, let us start by understanding a business problem and going all the way to putting out something that would help solve that problem. This graph, it's not really a graph, is it? It's a diagram. This has got to be the best known thing about CRISP-DM. It's so well known that last week at another conference, I saw someone show this without the caption explaining what it was, without ever referring to CRISP-DM. I'm not even sure that he was familiar with CRISP-DM, but he sure as heck knew this diagram. And when I say this diagram, I mean this exact diagram, right? So it's become so popular that it's floating around in places where it is disconnected from its original association in the sense of that particular project. And why is that happening? Well, because it's not only those of us who identify as data miners who can use this process. And for you who identify as data scientists, is that true of most of you? I'm getting it's Sunday morning. Having this process and thinking it through is valuable to you, because I can tell you right now that there's not one business person on earth who cares what Python package or R package you are using. So this will help you to communicate and think the way that the folks who are paying would like you to think. So, all right, so we see there are 6 phases: business understanding, data preparation, modeling, evaluation, deployment. Let me talk through very briefly those 6 phases. But let me take a second before I do. This is the most popular process among data miners. Right? I could give you poll results. I can also tell you the polls are not entirely unbiased. They're not even close to unbiased. But I have very broad experience, and I know from that as well. This is the dominant process. There's really only one other well-known process, and that is proprietary to one of the software manufacturers. So this is it, folks. It has these 6 phases, and while many, many, many people say we use CRISP-DM, what they mean is usually we're aware that there are these 6 phases, and we kind of do something like that. They don't really take advantage of the full depth of the process, and often that's because they haven't read any more. And I can understand that that's not so easy because there's a wonderful guide, and it provides a lot of depth, and it's 75 pages of small text. So not everybody who says they use CRISP-DM is really aware of everything it involves. So let me give you a flavor of that. So the first step is business understanding, and it sounds very simple. Here's where you get a clear understanding of the problem you're out to solve, how it impacts your organization, and your goals for addressing it. And there are 4 tasks. Now, identify your business goals, assess your situation, define your data mining goals, and produce your project plan. If I substitute data science for data mining, do you do that? It's only a rhetorical question. I'm getting a few nods. I'm getting a lot of no nods. Let me go a little deeper. In fact, CRISP-DM defines what tasks should be going with it. So there are deliverables, specific deliverables, that for just one, identifying your business goal, you would have to give background, give the broad goal of what your organization is trying to accomplish, and very specific, if at all possible, with something measurable, like we want to increase sales by 10% this year. Not all sales. It's not sales related to the project. And then define how the results would be measured. So these deliverables might not be very long, but they're specific deliverables that it's very important to define. And in fact, just for the business understanding phase, there are 12 deliverables. So what you just saw was for the first task, there are 3. We can see that there are more in each task. Some of them are short, like the ones I've just described, but in fact, 3 of them are in-depth report. 5 are in-depth reports. So in fact, merely getting an understanding of the business problem that's good enough to go calls for you to do a lot of things. Doing these things means that you will understand clearly what's actually valuable to management before you go off and do all the work. Because it is no fun to have that experience. Who has ever done a lot of work and then had management say, this is not useful to us at all? Yes, only one person's admitting, but it's, oh, more hands are going up. Yes, because it happens, and it happens a lot. And I will not swear that you can ever guarantee that a manager will not at the end of everything say, we can't use this. But it will happen far less frequently if you make the effort to do this. All right, now I'm not going to drag you through every deliverable of every phase, but we have 6 phases. So after a significant amount of effort to understand the problem, which is very valuable, all right, we go on to understanding the data, assessing its quality, describing it, and I mean describing every single variable or field, if that's the term you prefer, and assessing what's there, how good is it, what does it look like. Data preparation. Data preparation takes what percentage of the time? A very big percentage of the time. Some people say 80. I've heard plenty of people say it takes them more than 90. I hear people saying, oh, it's less than half the time, our data's good. Yeah, I don't believe, I mean, I believe they spend less than half their time on it, but I don't believe the results are good. Okay. And then modeling. The fun part, then the modeling, yay! Now, in data mining, we cheat. Let me make this clear. Data mining is statistics for cheaters. This is part of how it's made accessible to business people. Now, it's important to say this. I do not believe, and most experienced data miners do not believe you should dive into data mining as a business person with no training. And what's more, I don't believe you should dive into data mining as a data scientist or a statistician with no training. It's a different style. But when we talk about training, I'm talking about a few days of training, not a few years of training. So you get models, and the problem then is this, that the way that data miners use all the modeling tools available to them, it's not backed up by theory. It's not backed up by theory at all. Why? Because you're using available data, so we haven't sampled carefully to get what's relevant. You're not checking that the assumptions behind the algorithm are actually met. And even worse, data miners really like ensemble models. And maybe you really like ensemble models too. And who am I to tell you no, but I will certainly tell you this. There's absolutely no theory to support the use of your ensemble model. So what do you have to do? You have to test and test and test, and that's evaluation. So now that you've gotten your data ready, you've created some models that you think survive tests, you deploy them. You put them out into the everyday business contexts. And all of this is a cycle. And at every step, at every phase, there are steps you should take. We call them tasks in CRISP-DM. And each task may have several deliverables. In fact, even more deliverables than are described in the step-by-step guide, because for reasons I've never understood, it doesn't describe the data sets as a deliverable, but you better be delivering those too. So why would you want to use this elaborate process for doing your work? It is, in fact, practical. The idea is not hard to understand. It's always tied to a business problem. And that very first step of business understanding is one where most analysts, and it really does not matter what you call yourself, a data scientist, a web analyst, a statistician, in fact, most data analysts are very weak on understanding and explaining why their work is relevant to the business. And in fact, often fail to make work relevant to the business from the manager's viewpoint because not enough time is put into this. It's really fun to jump into modeling, and it really means nothing to management. Now, this is common across just the widest possible swath of, let's say, our kind. I've done talks or entire workshops for students from some of the most respected analytics graduate programs in the United States. I've done them for working analysts with anything from very little experience up to folks who came in and said, oh, I've written a book too. And they have. But when we ask them to explain what they've done in human terms, most have a very hard time with it. And it's worrisome to me that I often ask people, all right, well, but what does the data represent? Who are the people? What problem are they facing? That really, more often than not, analysts are not able to turn it around that way. Now, I think it's a little harder because when I ask them, they're at work or they're at school. I think if you were home, well, not home, maybe home with a glass of wine or in the pub with a beer, you would have a much easier time, and it might be how you talked about it in the first place. But there's something about being in the workplace and telling human stories that is less comfortable. So having thought it through before you start means that when you're explaining at the other end, you're going to do it better. It also ensures that your work is done thoroughly. And when I say thoroughly, it means you don't work alone. You're working with a lot of constituents from a lot of different viewpoints, right? You'll work with IT people who want to know why should they let you into the data. You'll work with managers who want to know why they should be paying you or listening to you. And you may work with a whole host of subject matter experts. And they need to feel that you are worth their time. Also, on the other hand, they may feel you're worth their time. They may not understand what you want to know. And if you can't explain it to them, they're not going to give you the right information. This is evergreen, right? It was defined by people who call themselves data miners. So what? With the exception that you might care more about using models that actually have a theoretical basis before you choose your techniques, every single thing that goes on in here could go on, and you could call yourself a data scientist, a statistician, or any of a host of other analyst titles. And it's never going to change. And hey, it's free. So it's there for you to discover and take advantage of, and very flexible, so you can adapt it to your particular needs. As I've said, it's popular. It's used around the world. It's used even by people who don't call themselves data miners, but it's not necessarily done well. And that is a big concern. It's not necessarily done well. So we have a big constituency, but we don't have a really great organization behind this right now. That special interest group brought together so many organizations, and they really put in a lot of work. It took a couple of years to produce the step-by-step data mining guide. And it was a very interesting process because I was at the time working with some of the people who were involved. So what I know is across this wide range of industries and roles, people might have liked different methods, different tools, but their process was very similar. So there was tremendous agreement on that. But once the document was created, no more funding, no commercial interest really pushing it, the organization quietly dissolved. And that's created a lot of problems. Okay. So there are problems with distribution. Problems because there's a lack of education and because there is no institution, or has not been, behind CRISP-DM. So what's gone on now is that lots of people use the term, lots of products have some elements of CRISP-DM built in, but not all the elements. Okay? So there's a document, and it's absolutely free. Have fun finding it, because it does not come up first in the Google results. It's on the IBM website somewhere, and even I have trouble finding it, okay? And I know exactly what I'm looking for and where it's going to be, and I still have trouble finding it. It is, as I said, 75 pages long, and the type is not very big. And then if you get it, it's not really clear. Can you share it? Can you give it to other people? If you want to quote from it, whose permission would you ask? None of this is clear. So this has been problematic. So there's been a lot of distribution of the general ideas, but getting into the details, that's been weak. Okay, so I would say that that was weak from 2000 when the document came out until last year, and still needs improvement. A lot of books have mentioned it. Not many go into depth. A lot of tools bring in some bit of it. A broader education problem is that, let's say you want to learn about this. Live classes are hard to come by. Why are live classes hard to come by? Well, Follow the money, right? Someone needs to pay for a live class. Who owns the dominant products? IBM now owns the dominant data mining product, and IBM doesn't do training anymore. Okay, in case you weren't aware of that, IBM does not do training anymore. So that means that their partners have to do training. Okay, well that sounds good, except IBM closes the sale on the software and then have fun meeting a partner. They'll introduce you, but if you don't know if you're going to get training business, you're not going to invest in developing it. So there are a few partners doing training, not very many, not many people. SAS and each of the other somewhat dominant data mining companies, they do some training, but you know what the training is? It's mostly how to use this software. It's not what's a good data mining process. Not many classes at schools. There are many web resources, but they're not that great. And the books usually only touch on it, and they can get very academic, except that there's this new book which boils it down. So that was a big mission of mine when I set out to write Data Mining for Dummies, which describes CRISP-DM in 25 pages of bigger type. Okay. So that's a step. One book is not going to meet everybody's needs, so people are going to need more details slanted for their particular approach. So maybe there's a need for a book for Python data experts to have CRISP-DM explained in the flavor that suits you perfectly, and maybe one of you is the person to write it. No organization, because there's no financial interest in it historically. But there's a change there too, is that last year the Society of Data Miners was founded. And it was founded by 4 very experienced data miners who happen to live right around here. So the headquarters of the Society of Data Miners is right here in London. And it's now the focal point, the institution that's positioned right to take CRISP-DM forward and see that we do start getting the education that we need, and we do enhance the existing document with more examples, and start seeing that there are more books, more web resources that provide the professional slant that suits different kinds of users, the language that suits different kinds of users, the level of depth that suits different types of users. So for the PyData community, what's the challenge? The challenge in your work is always to produce value for your employers or clients, to have a good work process that's efficient and effective, and also to be perceived as someone who is doing those things. Because if you are not perceived as providing value and doing so efficiently, what's going to happen to you? Not the ideal things. CRISP-DM will provide value by assuring that you're doing something that's relevant. It'll maximize the chance of producing a positive ROI, which in fact is a lot rarer in analytics than it ought to be. Okay. In text analytics, I have actually seen poll results from a pretty good poll, which still shows and has shown for years that the majority of people who enter into text analytics do not break even. I have never been able to find any kind of good numbers on analytics in general. I don't think it's quite as bad, but in fact, many people don't break even. And they don't break even primarily for just one reason. They never made a plan to break even. In fact, most of the success stories, I shouldn't say most, that's going too far, but many success stories that you hear for any kind of analytics, they are backfilled by which I mean we played around with analytics and then we've got to justify what we did. So we're going to find any success in the business that was in any way tied to data analysis, and we're going to claim that. And that's baloney. You don't have positive ROA unless you started off with a defined goal and, in fact, have measurable positive returns by that goal. And let me give you a little hint that managers don't tell you. If you're about to propose a project and you need to show how it's going to produce benefits, I, as an analyst, always think, ooh, the big benefits are in increasing revenue. Do not make your business case on increasing revenue. Make your business case on decreasing costs, and you're more likely to sell your project. Because management believes you can decrease costs, they don't believe you can increase revenue. And the political complexity of deploying something to increase revenue is much greater. So they may also know that they can't execute on that. That has to be your secondary benefit. And what's more, you use this process, you're going to document better. You're going to make sure you've done the steps. So you're going to protect your own role, and you're going to protect the work that you've done and maintain that intellectual property for yourself, your client, your employer, something that data analysts are generally weak on. The process is going to ensure that you work in an efficient and consistent manner, and as I said, that you document, so this is not a biggie. And if you do it this way, because you will have thought through what am I doing, why am I doing it, how is it relevant to the business, you're going to be understood better, you're going to be able to demonstrate value better, and that means that you just might get decision makers to do something. Okay, they'll be more willing to respect what you've said and act upon it. And really, what is the point of what we do if no one will act upon it? Quick one, who here has the power to take action on every recommendation you make? Is it you? Raise your hand if you can take all the actions. No? Nobody's hand. Yeah, usually one tentative hand goes up and then comes back down. Right? So if we cannot influence management, our work is just work. It's not productive work. So we've got an opportunity, all right? You can read about CRISP-DM, so you can download the CRISP-DM step-by-step data mining guide, which I now realize I forgot to put the link to in here, but I'll send it to Florian, and it will get round. Or you can write me personally. I'm metabrown@metabrown.com, and I have piles of cards. You can try Googling just by that name. Tell me what you get. You can read the book. You don't need to buy it. Go ask your library to get it. From what I can tell, it's only in 8 libraries in the UK so far. So nag your library, it's cheap. And yeah, you can buy it, and I will not object. And there is more information out there. Be a little cautious about what you read and judging the source and the quality, but there is more out there. You can learn from people who've been involved in data mining for a long time by getting involved with the Society of Data Miners. Again, they're based right here, and it is a very young and very informal organization right now. Everybody's welcome. Everybody will always be welcome, but everybody's really welcome right now. And you can adapt this to your particular working situation and style. So please come, and lead among your profession the use of CRISP-DM and take it forward. You can reach Society of Data Miners through their website, socdm.org. It is not the most stunning looking website you've ever seen, but there's contact information there, and you can tell them that I sent you. Everybody in the founding committee knows who I am. I am actually, other than the 4 guys who founded it, I am the first member of the Society of Data Miners. I was just waiting for them to finish it up. And at least one of them has worked with me for many years. And tell them you're interested in CRISP-DM, you want to learn more, you want to get involved. And I have spoken personally with the founding chairman and told him, this is my call to action, and confirmed that yes, they can get in touch with him personally. His name is Tom Kabaza. And if you look him up, you'll discover his 9 laws of data mining, which are also very cool. Again, where to find the book is here. Where to find me. So it's all in the slide deck, which you're going to distribute, yes? Thank you, Ian. And if there are questions, I'm very happy to answer them.
We have a couple of minutes.
Yes, sir. I'm going directly to the gentleman with the loud shirt.
I come from software development background, and this feels to me a bit like analogous to a waterfall method, which is, has come to be realized in software development, is the worst way to develop software. It's based on the principle that the customer knows what they want right at the start. Yes. You give it to them, and they realize that's not what they want after all.
Okay.
And it feels to me that this, you have to write half a dozen or more reports before you even look at the data, whereas looking at the data may give you more information about the business, may give the business more information about the business.
Okay. All right,
so I'm just wondering how you would respond to that.
First, it is very offensive to data analysts to tell them you have to write things down and you have to write reports. I know, tough, because your managers are not high-level managers, not the guys and gals who control the money, are not going to sit and spend time with us. They will not. So things must be written for them. And you know what? When I say they're written for them, they're really written for the person 1 level below them, because they don't read this stuff either, right? So we write this stuff, and yes, you do write it down, primarily for the benefit of the person who reports to the manager controlling the money, so that that person can first get an overview and know what to think and say quickly, and second, when questioned, go back into depth and get more information. All of these processes are a back and forth. Now, I hear what you're saying. It's a cycle. Okay, so none of it, in fact, is straight round. It may not be well represented. So it does all go back and forth. And yet, it is, in fact, the way that business works. So I know what you're thinking when we're thinking of the, I'm blanking on the term of the iterative development with the 2 people working together and all of this. The guy.
Agile, the XP.
Agile is the term that I was looking for, though. And it doesn't feel that way. And by the way, no one on earth puts 2 data analysts working next to one another in any business context. I know you're lucky to get 1 person. So is it a little different style? It is all a back and forth, so it's not a straight line at all. But at the same time, is it just like an Agile or any of the similar processes? It is not. I think it could be adapted to that? Yes, but not so much that you don't have to write things down and you fly by the seat of your pants. Forget it. You're not going to get managers to sit and look at what you're doing playing along in analysis like that. It is absolutely unrealistic. And why is that different from the software? Because the place in the organization where people look at your software is at the user level. And they might be willing to look every day or every few days. And this, you're asking management to take an action, management to commit resources. And just to give an example, I heard a talk last week by a very, very high-level expert analyst, not someone down at the ground level, but you know, a vice president level person who runs an entire team of managers at a very, very important multinational corporation. And he talked about being asked a few days before the United States Thanksgiving holiday, which is a huge holiday, to produce a certain analysis, right? So he was working nights, and he produced his nice, brief 10-slide presentation, and he sent it to the executive, and he hadn't heard back, so he went, right before the holiday to check. And the man looked at him and said, "It's 7 p.m. Thanksgiving is tomorrow. Boil it down to one phrase." That's right. I said one phrase. That's the amount of time he was actually willing to put in on it. So you simply do not have the audience who's going to be engaged with you all the way through as you would in an agile software development process. Yep.
We have time for one more question.
Okay.
Hi, great talk. Thank you. I would ask you, you said you are a statistician and data miner, and referring, for example, for machine learning area, there is a really horrible thing happening here, with all these nonlinear models, and I see lots of cases when people use nonlinear models with very complex hypotheses with very, very lots of features on very small data sets, and things like Kaggle is doing this more popular even, and people don't care about some Vapnik-Chervonenkis dimensions or mass, but they have an excuse. They said, I have done cross-validation. So yes, I have done 50K fold validation, and it is okay.
Okay. All right, so let's make sure, I'm just going to repeat the question on that one. All right, so the question is, look, right, so I've talked about data miners, and data miners cheat, right? They use algorithms that are completely inappropriate to the situation. and then they get something that looks good. And then in the example you've described, they say, it's fine because I've done cross-validation. That's not enough testing. Okay. So what do I mean when I say that data miners test? It means, first of all, that data miners hold out some data and don't use it to build models. And if you're lucky, you hold out several spare data sets if you have enough data. And you try what you've done against these several sets that were not used to develop the model and see if it still works. It will usually fall apart right there. If it still holds up, you must field test on a small scale. Okay, so field testing, I mean you have to go out into the world and see if it still works in a new situation with new data that never existed before. And only if it gets through all of that have you really got something that you can then say, yeah, we're going to deploy this across an organization and use it in everyday business. Just saying it cross-validates is not enough, even for a data miner.